Welcome. In this lesson, you'll discover how real technicians use fuel trim scan data in context to trace the true source of a drivability or efficiency problem, without falling into the trap of unnecessary part replacement. Fuel trim numbers show the ECU's reaction to the difference between measured air and actual combustion results. The module can't see the real mixture or sensor performance, only voltage inputs and pre-programmed logic. Before a fault, these values follow predictable patterns as conditions change. To turn scan numbers into proof, always match the observed fuel trim to the engine's true state. For example, positive trims during a vacuum leak are expected. But if both upstream O2 sensors read lean with a normal MAF signal, something doesn't add up. You need to look deeper. Related PIDs can confirm or challenge scan data clues. When fuel trim looks off, compare related sensors. Does the MAF support the same story as the O2s? If not, measure intake leaks, exhaust leaks, or sensor grounds directly. Never decide from a single PID. Use targeted tests, like a smoke test for vacuum leaks when trims are high positive and O2s agree, before replacing anything. Serious faults often affect more than one scan value. Pairing LTFT, STFT, O2 sensors, and even MAF or MAP can prove whether a trim number is believable or a clue to a sensor, wiring, or ground issue. Outliers among these values help pinpoint the true cause before any part swap. A common pitfall is jumping straight from a fuel trim number to a new O2 sensor or MAF. This guesswork leads to wasted time and expense, as the real issue could be wiring, vacuum leaks, exhaust leaks, ground problems, or even software. Always prove with related tests before making any purchase. Interpreting fuel trim scans is about confirming system logic, never about parts guesses. Compare data to conditions, prove findings with related signals and real-world tests, and follow a trusted diagnostic flow. You'll solve more problems, avoid wasted money, and earn greater trust. You've just learned how to turn fuel trim readings into reliable diagnostic guidance without the costly mistake of unnecessary part swapping. To master scan data for other systems, keep watching STEP.